Pushing the button. Yay, here we are. Hey, welcome everybody to Astronomy Daily Live. It's 2 hours UTC on July 4th, 2019. Welcome everybody. Hope everybody's doing well out there in the universe and the world. So sit back, relax, just forget about things. Let's think about astronomical stuff and spacey stuff and sciencey things just for a little while. Just let everything else go and let's just have this a nice chill spot, have a little bit of fun, relax, and talk astronomy for a while. Now, I've been doing this exact same thing for years and years and years and years and years. It's just recently, in the past year and a half or so, that it finally dawned on me. It's like, well, why don't I share it? I love doing that. I absolutely love it. So it was really, really easy to set up a little camera, extremely primitive setup here, but it works. What really matters is sort of the content and the conversation and all the participation and everything, and then the icing on the cake, right, is the astronomy and the science and all that awesome stuff. So come on in, everybody. Welcome. Glad everybody can be here again on this auspicious day. So let me look at the chat really quick. So Uncle Bill was in really early. He brought his crickets with him, so you gotta watch out for the crickets because they're they sort of get everywhere. Let's see, Carolina Sky Astronomy. Hey, nice to see you there, Jim. Chuck, nice to see you. So yeah, grab your consumables of choice. I am double fisted here today. I've got the coffee and the HOH here. So yeah, everything is good. The coffee is nice and hot. So hold on. Excellent. All right. Well, hope everybody's doing well. So this is sort of an auspicious day for one primary reason and one sort of minor reason. And the minor reason is that at least here in the United States, July 4th is the Day of Independence. So back in 1776, some papers were signed. Some pretty interesting papers were signed, by a bunch of guys that said, "Let's do this." And I actually, I'm going to grab the handy dandy calculator here, 2019 minus 1776, and then you sort of have to add one. So if you do that, 244 years. Wow, pretty amazing. Now, that is all really, really exciting for 4% of the population of the planet. Okay. So does that matter all that much? Yeah, it sort of depends, right, on your perspective. But the one thing that is happening to everyone in about 20 hours or so is aphelion. And that is when the Earth is furthest from the sun. And whether we know it or not, everybody shares in that experience. That is a shared experience. And I like those. More than just, sort of these, not necessarily random, but a small segment of the population celebrating something, which is extremely cool. But all of us are as far away from the sun as we're going to be for the next year. And
so would tonight or tomorrow night be a good night for a fire then?
I would say any night is a good night for a fire, but you want to make sure that it's sort of like outside, you don't want to put one up in your living room or your office or anything.
Right.
Yeah.
I'm just saying we're farthest away from the sun. It might be kind of chilly.
Well, that's exactly true, and it's extremely counterintuitive for us here in the north that it's the hottest part of the year, yet we're furthest from the sun by at least several million miles. Perihelion happens in like January-ish or so.
And I don't think
And
we have any 90-degree days anytime soon.
oh,
Which is
okay,
kind of
yeah,
weird, considering they're all claiming global warming. That's a bunch of crap. But anyway, that's a whole nother subject.
yeah. Well,
But
things change. Everything changes, including the climate.
yeah,
For better or for worse, we are going through change constantly. Anyway, so enough about that. So I want to
Yeah,
say hi
enough of
everybody in the
that. Come
chat.
on.
Enough with all of
well,
that.
I was wondering though about the forces on an orbiting object. All right, we were talking about the moon and the
Hmm.
gravitational effects from the sun and the moon, right?
And the Earth, right?
And so, how does that? Can that eventually either deteriorate the moon's orbit and or cause it to break apart, meaning the moon itself to break apart, uh, or can it just mainly kick it off orbit and make it go away or whatever?
Yeah, I'm not exactly sure. It's a very, very dynamic system. But before we get into it too far, because somebody's going to explode here really, really soon, and I don't want to clean up the mess. So, Bobby, what's going on over there? How are you?
Nothing much. How you doing, Ron?
Hey, Bobby.
Yeah, sorry I missed the morning show and stuff. Was Venus on today?
I was on, yeah,
Well, but what about Venus?
huh?
Venus.
No, she was not. No, she's
Oh,
busy
okay.
with.
Well, thank goodness, because I was so freaking busy, especially
Well, yeah.
when that day is a check day.
No, she's busy with family, I think.
Oh, cool.
Oh, okay. That's
All right.
okay.
Well, awesome. So, yeah, well, hope everybody's doing well. Now, Ron, about this breakup and all that, I don't think that's a little extreme. What's
Well, the reason why I ask is if you take a look at the Martian system and you look at the two moons there's one moon that's actually closer to the planet now, and it's actually, I don't know if we'll get to see it, but there is a chance that someone's going to get to see it crash into Mars. Am I right?
Well, that's a good theory, but it's really, really, really hard to project too far out into the future what exactly is going to happen based on what we know now. I
But
think
what causes that deterioration of the orbit of the one moon?
what causes that?
Yeah.
Well, I think the idea is that both of those moons are captured asteroids. So they once had different orbits altogether, and those orbits continue to change even now. So I would say that it just sort of seems to be going on at the moment. And I'm not sure of the details, but those kinds of orbits do change, and yeah, I think the timescales though are pretty long. I mean,
All right.
we're talking thousands of years or millions of years.
Oh, yeah.
All right. We got Paige Master, and I think did we introduce? Did we say hi to Chuck?
I think
did
I said
not.
hi to Chuck. If not, I'm going to say hi right now. So, hey, Chuck.
Yeah.
Hi, Chuck.
So Page Master is in his WA 5136 SWL outposts. Great to
Okay.
see that PageMaster's got a shortwave listening call sign. I am also a Whiskey Alpha 5107 Sierra Whiskey Lima.
There you go. So
Okay.
pretty
Uh,
close.
Sounds like you're drinking over there, Bobby.
No, he's got that right on, man. Right on.
yeah.
Right on.
Saying whiskey though, I didn't think he's
Yeah.
drinking.
Nope, I don't drink.
No, I know you don't
But
drink. I'm kidding.
we like to welcome Niji in the chat.
Nietzsche. Hey, nice to see you,
Well,
Nietzsche.
you don't drink alcoholic beverages. You do drink.
How about Sprite?
Oh
There you
man.
go. There you go. I was just being technical. You do drink. Obviously, we all have to drink something.
Much better
Right.
to drink alcohol than that Sprite, though, Bobby. So I would switch if I were you.
Oh no.
Oh hell, no way, no way, no way.
All right. Well, cheers, everybody. I think what I want to do here now, for the next few minutes or so, is go back to the Mars InSight data release, and let's continue to look at that because we just sort of barely got into that at all.
Speaking of that exploration of that, same type of conversation. I was watching a drone that they had on astronomy on the APOD, Astronomy Daily Picture, and they showed where they released the drone, and then they had it sail across the planet's surface. And then it touched down and it got some kind of sample or whatever. Then it picked up and went again. If we could have a drone like that, can you imagine, of course, how much that would cost? Something like that.
Yeah, I think you're talking about the Dragonfly that's going to be going to Titan.
I think so. Yeah.
I'm actually looking at the APOD right now.
Yeah, and that was an awesome video what they showed. And I was thinking about what you were just describing with the Martian reconnaissance, whatever that one is called. Yeah.
InSight.
And, InSight. Yeah. What we were talking about with that, and just think about the technology of how we can go to another planet like that.
Well, I got to tell you, Ron, that the Mars 2020 rover is going to have a helicopter on it.
Oh wow!
So
Uncle Bill doesn't understand how capture moons or ejected like ours is supposed to be end up with orbits so nearly circular. Orbital mechanics doesn't work that way without additional delta B at apesis.
Well, I think one of the explanations for that is that we don't know all the things that are taking place there. I think that there are some forces that we are not taking into account. And
well, I think that's true in space in general.
Yeah.
Space in general, we don't know. We only know what our time. For instance, if we know what 24 hours is, we know what the the 24-hour clock or 12-hour clock, whatever it is. We know what that is. We know what we know what the day-night time system is. Okay, we got that. But when we get out to space, we're not going to have that day-night time system. We're not going to have the 24-hour clock system.
Yeah, well, I mean, we're still going to have time, but it's sort of going to be different. I mean, right? I mean, when we're on Mars, the spacecraft they're at and on Mars actually keep track of all these times, right? They keep track of UTC time on Earth. They have a spacecraft time. So keep track of all that.
Angie came up with a theory that when the Earth was still just like a baby or something, it probably became a ring system before coming together as a moon.
Ooh,
that's as like I always say, the best story wins because
I'll
we
pretty much stick with something smashing to the earth, jettisoned all those pieces, and then became a moon.
yeah,
Mm.
see, now those are two different models, and what we can do is we can sort of develop those models, with all kinds of ways to change all the parameters around.
Or my suspicion is that God just put it there.
That that's that's a valid one too. But then once we have these models, it's really 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 nice to have some data, to sort of
So
match those up and see
Mhm.
what's going
this
on. So,
ring system idea, I don't know if that was possible because it did say it had a ring system. Yes,
Really?
Space Ranger, that is correct.
yeah,
If it would have a ring system, there's a possibility it would have a ring system and probably not a moon.
right. And um, like I was saying the other day, um, it it seems to me that the Earth and the Moon um, sort of co-orbit the sun, as
Hmm.
opposed to the Moon goes around the Earth. So
Oh, yeah. Yeah.
so there are dynamics there that we don't understand. We don't know the history of this at all, and we never ever ever will because we weren't there. We just weren't there to record those events. So we really don't know.
So,
And the amount of data that we have now, even though it might be hundreds of years worth, is infinitesimal compared to the timescales that we're talking about. So we really don't know, and on top of that, we don't know what we don't know. So that's why I say the best story wins, and that's as good as we can get. So all right, let's look at some more InSight data.
just another episode of Unsolved Mysteries, Astronomy Daily Live Edition.
Yeah, and I have no problem living in a mysterious world. I think that makes it extremely interesting, right? I mean, if we understood and knew everything, I don't know about you, but I'd be bored. so
Mhm.
so I don't mind. I don't mind. I think that's just fine. So, and it's kind of fun, to find out things and try to work it out and see if it works. The scientific process itself is very, very fun, right? To kind of work on that kind of stuff. The sun is setting here in southeastern
Okay.
Arizona.
Yep.
All right, so I'm
Okay,
going
Chet, let's
to.
quit blabbering about the moon and let's go ahead with some Mars insight, shall we?
Wow, but the moon is so amazing, and its
I
history,
know.
the history of
I
the
know.
moon. I mean, what you're talking about is extremely um, uh, uh, really really cool. To think about. It's like, well, there it is. How did it get there? What's it doing? Why? Why is it there? Right? And
And if
and
tonight would have
there's
been a
all
good
kinds of
night
answers.
for tonight would have been a good night for the telescope, but guess what's gonna happen tonight? Tonight, tomorrow night, and all weekend basically.
Yeah, that
Get
Yes.
that stinks.
yeah.
But that's how
So
it goes. That is the life of
oh
the
yeah,
astronomer. So
yeah.
get used to it. That's it's just how it's going to be.
Oh yeah.
Um, but it makes those clear nights really special.
Oh yeah.
Really,
Well,
really, really.
my
It's
next
like,
clear night, I plan on taking my scope out and actually learning how to align it correctly.
good, good.
So
And you'll,
that's my
you
challenge.
know, yeah. Well, hopefully that'll be a relatively easy task.
Yeah.
It's a learning curve. It's a little bit of a learning curve.
Well, from what I
Um,
was reading about and from what Ada was telling me is that it's actually uh, once you get through the tedious part of it, I think it's actually pretty self-explanatory. It goes on its own actually.
Once you do it once or twice, 10 times, it'll be just like, what was
Oh
so
yeah,
hard about this?
that's right.
So no problem. Okay,
Yeah.
let us look at some more Mars InSight. So they just came up with a data release back like June 24th or something like that. So just about a week and a half ago or so. And you know, all the planetary spacecraft release their data periodically. I don't know if they're on any kind of schedule or if they just sort of wait until their memory banks are full and then they do a data dump. I'm not exactly sure how that goes, but once in a while.
But they do have like a calendar of when they're supposed to be releasing it, right?
I don't, I really don't know. I'm not sure if there is a calendar. I would suspect that they probably have a pretty good idea. Because like I was saying, I mean, all these spacecraft are sent up a pre-programmed set of instructions that lasts, a week or two or a month or something like that, and then the machines just run through the instructions. So they probably have a pretty good idea. Yeah. But all right, let's dive back into InSight here. Let's get some insight into InSight.
Mm-hmm.
So yesterday we took a look a little bit at the temperature. Actually, we never looked at the temperature and wind. We just looked at the pressure. But then we switched over to the two cameras on board. There's a deployment camera, which is sort of on the lander itself, and then actually the context camera is the one it's on the lander, and then the deployment camera is actually on the arm. But what I thought was kind of interesting, and I'm extremely curious to see, is that they actually have data from the deployment arm itself, and I'm trying to understand what kind of data would be there. So let's take a look. Instrument deployment arm archive. Oh, we got a doggy alarm. Okay, so let's scheduled. Oh, okay. So it looks like there isn't any data yet. You see, this is coming out, data release 2, apparently on October 1st. So, we're going to have to wait a couple more months there to see that. I'm really curious to see what kind of data they actually have. So the deployment arm has a camera, and that it actually, is used as a little what do you call those things? That move things around and lift stuff. What is that called? I don't know. Anyway, okay. Well, I guess I'm going to have to live in mystery for a few more months here. So, okay, let's move on. So here's the magnetometer. Most spacecraft have some kind of magnetometer just to measure the local magnetic field. Now this is a stationary lander, so it's not moving around. That kind of makes me curious to see what kind of magnetic field, or what the magnetic field is doing here. And I guess they have data from both the cruise and also on the surface. So let's take a look.
Oh, wow.
Okay, let's let's go right to the surface of Mars here. Let's not bother with the cruise. The cruise was I think it was like a 6-month trip, but let's just worry about what the magnetic field, the local magnetic field, is doing on the surface here. So let's go here. And let's see, I'm seeing a thing that's called calibrated. I know that's kind of hard to see. Let me zoom in here a little bit. I always sort of like to see, the calibrated data for this live stream. So yeah, let's dive into that, and we can see that. Okay, so it looks like it's divided up into 4 folders depending on this the Sol, to Sol 4 to Sol 29, and then 30 to 59, blah 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 blah. So I don't know. Let's take the second bunch here. So once it's sort of settled in, right? 30 sols after landing, it's probably pretty settled down. There's not going to be any real excitement from anything else. So let's take a look here. So, these files and folders are carefully named, but I'm not really even going to try to interpret this. This is probably like a date range, 2018, 12, 27. So that's probably December 27th, 2018. And it looks like it's going from 1:49:22 to 6:7:57. Now, if this is UT time or spacecraft time, I guess it's probably UT time. They're talking about Zulu here, so that's probably UT time, I guess. Let's just look at the first one. There's a lot of data here, it looks like. So let's just look at the first one. It doesn't really matter which one we look at. And here's some files. Okay, so there's a thing called a .tab. I'm hoping that that's an ASCII file. Let's go ahead and save it over on my local disk here. And let's see, I have to get to the right place. I'll just put it in the same place that we did yesterday. That'll be fine. It's not huge. Not a huge file. So let's take a look here and see what we've got. Yay, it's a text file. So somebody in the chat, PageMaster or whoever, might be able to find the documentation on this. I think this is pretty straightforward. This is the UTC time of the measurement, and it looks like this column and this column and this column are the XYZ magnetic field strengths. Now, I'm not quite sure what the units are here. The documentation, if we can find it, would let us know that. There's also these two things. There's a magnetic field north and a magnetic field east and a magnetic field down. Not quite sure what that means, but we should look at all these. It doesn't look like I'm going to be able to plot the time or anything because it's in this funky format, and GNU plot is going to have a fit if it tries to deal with that. MLST, that looks like it's an increasing number. Let's sort of go through here, but I don't really know what that is. So for the moment, at least, I'm going to ignore it. We can just look at the times.
If there's a possibility you'd be able to format it as a CSV, or what can you do so GNU plot will work?
Well, the reason why GNU plot is going to have a fit with this is because it wants to see just numbers. It doesn't want to see a date with hyphens and colons and all that kind of stuff. So I would just have to reformat this. I'd have to calculate some kind of fractional day or something like that. It's not really all that important. But what we can do in this case is we can actually do some three-dimensional plots, which aren't going to have a huge lot of meaning because this is sort of temporal data. The data is changing over time. So to plot X, Y, and Z in some kind of 3D thing, it's going to probably make kind of an interesting shape, but I don't know how much meaning there actually is there in terms of scientific meaning. But we can definitely look at these three things one by one, and then in sort of a 3D way, and we can look at the X, Y, Z and the northeast down and see what that's all about. So this first line, I'm just going to comment out so GNU plot doesn't try to do something with these weird-looking numbers here. So yeah, let's get into GNU plots.
And we don't have to set a data point, right?
No, we don't. By default, I think you're talking about a separator.
Yeah, the separator.
Yeah. And by default, GNU plot will look for columns that are separated by white space. So I think we're golden here already. So let's just look at each of these individually, and then we'll do some 3D stuff. Sometimes the 3D stuff is pretty interesting looking. Sometimes. So let's just look at the first one first. So that's column 1, 2, 3.
Now, you want to do a 2D or 3D?
I'm gonna do a 2D at the moment. So it's just going to be data point versus b sub x. In this case, I'm going to use column 4, right? 1, 2, 3, 4. And let's use lines with lines. Line with 1, line color 8, which is black. Here we go. Let's see what it looks like. So this is the measurements of the strength of the magnetic field in the x direction, which is probably defined somewhere as well, but by a stationary lander. So the lander isn't moving. These magnetic fields are sort of moving around it. So yeah, we'll see what it looks like. I don't know what to expect here. It's probably some kind of sinusoidal thing, but who knows? Let's take a look. Bam.
There it goes.
Yeah.
Looks okay to me.
Yeah. So what this is over the course of about 5 hours or so. And again, I'm not quite sure what the units are here.
And I just want to know before you continue, I just became your 3rd Patreon.
Yes. I was going to thank you for that, and remind everybody too that besides this live stream, I am doing some pretty cool research, and if you would like to support that, go over to my Patreon page. Just look for Cosmic Lettuce, and you'll find it over there. And yeah, I'm doing some pretty cool things, and you get a little bit of insight into what I'm doing, and lots of details. And all patrons get access to the kinds of things I'm doing. And then there's a couple of different levels. So check that out. if you want, thank you to all the patrons. I now have 3 patrons, so that's that's absolutely fantastic. I think that's great.
Yeah.
All right, well, cool. So, yeah, look at that. It's there's quite a huge variation here too. It's going from what 1285 down to 1310. So that's pretty significant, and lots of bumps and wiggles and all that. So this is the X direction of the magnetic field. Let's look at the Y direction. That's going to be column 5. It's probably going to look about the same. Yeah, more or less the same. Pretty interesting, though. You know, this is the magnetic field strength sort of moving around, right? You know, the spacecraft, the lander itself isn't moving at all. So that's some pretty significant wiggles there. Kind of interesting. Didn't really expect that. So let's look at column 6, right? 1, 2, 3. So X, Y, and Z. So let's look at the Z axis here. See what that looks like. Oh, okay. So not quite as wiggly as the X and Y. Really, really amazing, though. What is going on here? I don't know. So let's look at the north and east and down now. So that's column 7. So this is the magnetic field north, whatever that means. Looks a lot like the X. Looks extremely similar to the X-axis. We can actually look at both of those at the same time if we want. Let's you know, I'm going to shorten this a little bit. Let's just call it ifg.tab. There. That'll be a little bit easier to deal with. There we go. So let's look at that one. Let's look at 8 and 9 at the same time. Look at all at the same time here. Let's see. I want to go back. Oh, it's gonna have a fit when I do that. That's all right. So that's 8. And
Yeah.
9.
There, I think.
Oh, I know. Yeah, it gets messy, but it's easy to deal with. Okay, well, because of the scaling, these plots aren't going to look all that great. It looks like the down. What's it called? What? The north. The north. Sorry. Yeah, the north and the down look like they're down here, and then the east is up here. So, yeah, I think plotting all those at the same time, that's probably not a good idea. So, well,
It was a good try anyway.
You have to try. There's no harm in trying things like this. So let's look at 8 all by itself. So that's the magnetic field east as a function of time, essentially time. And here's the magnetic field down. Oh, let me. I think I sort of messed all that up. Let's. Man, it's bad typing day today. Here we go.
There we go.
Yeah. So let's do some 3D plotting here. That's always moderately entertaining. Where am I looking? Oh, you need to do this now. So let's do a 3D plot of X, Y, and Z. Could be a little interesting, I suppose. What is that? 1, 2, 3, 4, 5, and 6. 4, 5, and 6. line with 1, my column 8. This should probably look a little bit interesting. Huh.
Looks like you just made the Swiss Alps.
So here, one of these axes is X, one of these axes is Y, and one of them is Z. You sort of see it's, well, it is for sure complicated. Now, time, in this case, sort of follows this line around. So if you were so bold, you could actually follow that line around from the beginning to the end, and that would actually give you how the 3D magnetic field is changing. I should actually make a movie. It'd be pretty easy for me to make a movie of this structure forming over time. But wow, look how complicated it is.
Maybe you should do that instead.
Well, yeah, let's maybe I'll reserve that for another time. It's pretty easy to do, but I'd have to write a couple of scripts and stuff. Well, at least one script to do it. So I would much rather, just look at the data and go, wow, for a little while. Look at how this curls around here. Isn't that amazing? Okay, so that's X, Y, Z. Let's look at north, east, and down. So that's just 7, 8, and 9. 7, 8, 9. Probably going to look about the same. That's my expectation, at least. Yeah, looks more or less the same.
Okay, so PageMaster has the link of the data dictionary of the PDS4.
Oh, good. Okay. That might come in handy, so keep an eye on that. Let's look at another chunk of time here. See if there's anything else interesting. I think we looked at the first one. Why don't we go down a little bit? How about this one? This is January 15th, 2019, from 14/24/20 to 15/03/54. So how long is that? That's wow. So that's only what, about 35 minutes or so, something like that. Not too long. So yeah, this is only 35 minutes of time.
Okay, and he also provided the PDS for Data Providers Handbook as well.
Awesome.
PageMaster, if you're on Discord, maybe you put that somewhere on Discord and stuff. That would be great.
Yeah, that'll be great. That'll be absolutely awesome. You can sort of put it either in the live stream channel or, wherever you want. It's fine with me. Okay, so let's rename this one too, but let's call it IFG2. I love my naming conventions. 2. So yeah, so only 35 minutes worth of data. It goes from 14/24 down to 15/03. Looks like just sort of looking at the timestamps here, it goes, it does 1, 2, well, here, let me count it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It looks like every 5 seconds or so, right? So every 5 seconds, they're taking a data point. Wow. Okay. Cool. let's take a look at it. It's probably going to look about the same as the other stuff, but we'll find out. Let's do X, Y, and Z first. So that's 4, 5, and 6. Look at the 3D first this time. Is that about right? I think that's right. Bam. Okay. So different, but sort of the same kind of look and feel, but pretty different. Let's actually do them both at the same time. How about that? We have the power. Some 4, 5, and 6, and we can do a line color 7, which should be reds. So we can do both of these at the same time. So the red one was the one before, and the black one is the one that we just grabbed now. So you can see how it changes. Still, sort of in the same area of number, right? It really hasn't flown off anywhere crazy. It looks like the range is still, staying about the same. But look at this amazing detailed structure. Let's look at the data points. Instead of connecting all the points with lines, just look at the points themselves. That's sometimes moderately revealing. Points. Point type 7 means they're going to be round dots. Point size I'm just going to make really small. And we'll do the same thing here with points. Point type 7, point size, Okay, here we go. So, I mean, this is going to look about the same. It's just we're not going to connect any of the points with lines. We're just going to look at the individual points. So it'll look about the same. Yeah. Little harder to render because it's rendering points and not lines. But if you're into art, here you go. You got some some interesting modern art there, which is actually something I do. I actually take this kind of data and I actually do turn it into art. So it'd be kind of interesting to see what I could do with that. I don't know. Maybe just throw it in the trash. I don't know. Kind of interesting though. Should we grab one more set and then we'll move on, huh? Let's see. Let's go back up here and let's look at the last one. At least in this list, Sol 59 from January 26th, so just a few months ago. Take a look and see what that looks like. Pretty small file. I'm just going to rename it right now. IFG3. So let's go back to the. Let's IFG3. I just want to comment out this first line. I don't think I have to, but I'm going to anyway. I don't think I did it up here. Oh, I just removed it altogether from that one. Okay. So let's look at the lines first. This thing's going to be a little bit ugly, but that's okay. 4 maybe? IFG3, right? Just this little thing right here. Wow. What did I want to do? Oh, I want to change the color. I don't really like that color all that much. See if that one's a little bit better. Well, it's a blue. So yeah, actually, not, on this scale, on the scale of the other ones, this is really, really, really small, or there's just not a lot of data there. Why don't we look at that individually? We can let GNU plot scale it for us here. We'll just see if there's anything interesting in there at all, or if there just isn't a lot of data. Who knows? Oh, ooh, okay.
Oh, wow.
So, yeah, hard to know. It's probably better to look at the data points here, because those lines are connecting all the dots, and sometimes that is not the best way to view this. Let's do it this way. Okay, so yeah, well, it is what it is. It sort of looks like things change. Maybe the instrument was turned off. I don't know. Let's go back one more. I said that was the last one, but you know how it is. Oh, look, this is the 20 hertz stuff. Let's do.
Okay. And while cosmic decides on this day in 1935, Harrison Jack Smith was born. He is a retired NASA astronaut, geologist, and a university professor. He served as a senator for New Mexico for one term starting in 1977. Schmidt flew on Apollo 17. He and Gene Cernan spent over 20 hours on the lunar surface collecting samples and deploying scientific instruments. They were the last men to walk on the moon.
Jack Schmidt, 1935. Very cool. Yeah, Jack Schmidt.
Is Jack Smith still alive or did he die?
Not sure. Not sure.
A good Wikipedia search would be good.
Yeah, I think he is one of the few actual scientists that went to the moon. As opposed to, like some kind of
Wow.
military dude. Still alive. Cool. I figured, 1935, to 2019, he's what? He's only in his 80s, right? Is that right? So that's pretty young still.
Let's talk to him. Get him on.
Hey,
makes me want to think if Bob Barker's still around.
Bob Barker?
Yeah.
I think he is. I don't know.
Maybe Ron would know.
He's invited over here too. So let's see what that looks like. There we go. Wow, so that did this wild excursion here. Isn't that wild? That's crazy. Lines, line with one. Huh. Yeah. It's it's hard to tell with the scaling here, but it is definitely pretty flat along the z-axis. It's not very wide here, but if you look in x and y, it's more extent. But look at all these details down here. Just lots and lots of little wiggles and things. It's horrible how I need to look at things closer and closer and closer every. Let's look at the first 10,000 points. Let's look at the first 1,000 points. How about that? So I would think that we might be starting to see a little bit of noise with the measurement itself. But pretty amazing how the local magnetic field changes over such a small period of time.
Yeah. I
This
think
is,
what Uncle Bill Druin said is true. The
what's that?
saddest part when we gave up the moon, that they were only just beginning to train scientists instead of just pilots.
Yeah, yeah, that's true. That's true. Let's look at, so this started at about 21 hours. Let's look at data point 1000. What was that, 1,000 or 100?
How does that work when the science doesn't match up with what you've been taught? So, for instance, like you might learn something in geology, and it's totally opposite of what you were actually taught.
Well, they
There are situations like that.
oh, that's happening constantly, constantly. So yeah,
Good
I mean,
points.
what you have to do is you have to rewrite the books.
Nah,
So look,
reevaluate what you learn. Yeah.
yeah. I mean,
Uh, I,
we should do that all the time anyway. So it looks like the first 1,000 points goes for about an hour.
Then you publish, Uncle
What's
Bill.
that?
Then you publish it after you write.
Yes, you must publish. Must publish. So yeah, the first 1,000 points here runs for about an hour and 23 minutes or so. So that's sort of what we're seeing here in terms of the extent of the data. So over the course of less than an hour and a half, the local magnetic field is wiggling around. It's not wiggling around a lot. See the z-axis here is only a couple of points, and this axis is only about 5. This axis is only about 4. So it's not wiggling around a lot. The amplitude of the wiggles isn't all that much, but the frequency of the wiggles and sort of the structure of the wiggles is, wow, just all over the place. Let's look at the next 1,000 points here. We can go from 1,000 to 2,000.
So, what does when we see the pressure of the atmosphere, what does that tell us about the planet itself?
Well, it's sort of giving you an idea of the climate of the local area and how the pressure changes over time. And then I guess you can use that information to sort of extrapolate a little bit to give you an idea about what the planet is doing. But yeah, that I think is to be determined. That's why this data is released, because now we scientists can go into it and start looking at it and say, what is going on? Why is it like this? Why is it doing this? Why did this do this and then all of a sudden change direction?
Yeah.
Why did it do that? So but we have to have the data in order to look at it first. So this is sort of the at least one of the first steps in the scientific process is to collect your data. But it definitely doesn't end here. We have to look at it and like I said, say, what the heck is going on here? How many data points do we have? We have 17,000 data points. Let's go from like 11,000 to 12,000. Huh. Pretty cool. So that's 4, 5, and 6. We can look at 7, 8, 9 too. Oh, should look about the same. Yep.
I kind of have to laugh with this Minnesota here when I'm not supposed to have anything that flies in the air, fireworks wise, and
Oh,
that's all these people have here.
yeah.
So we're out here in the middle of the cornfield. Why can't you have anything that flies up in the air? But yet the Minnesota state law says we can't have anything that flies in the air. Because
One of the great things that I really appreciate about laws is, or well, so-called laws. They're not really laws; they're rules.
yeah,
One of the things that I really, really like about rules is that they can be broken.
oh yeah,
I love that part. That's my favorite thing about rules, is that you can break them.
oh yeah. As long as one doesn't hit my house, I guess I'm all right.
Yeah. Ooh, look at that. So, like I said, you can follow this line, and that's actually time.
Oh
And
yeah.
I'm not quite sure if it goes this way or this way, but fact of the matter is that tracing all this out, you're actually moving through time, and you can see that it's that's just absolutely fantastic. Very, very small though, very, very small changes, but it's not static. No way, not even close.
Mm-hmm.
So kind of interesting, pretty amazing. I don't know. Yeah, there's
That's a frequency then? Is that what that is, or what is that?
I'm
What is
not
that signal?
not sure what you mean about that, Ron.
What is that signal that you're getting on the printout? What is it? Is it a radio wave? Is it a frequency? Light frequency? Sound
No, no,
frequency?
no, no, no. These are the local magnetic field strengths
Oh,
in X, Y, and Z.
magnetic.
So yeah, magnetic field.
Interesting.
Yeah, I think so. I wasn't expecting it to be quite this dynamic. I was expecting lots of wiggles and all that, but there's a lot of things going on in there. Pretty amazing. Let's look at the other one. Oh, let's look at number two. Yeah, we can do that. So again, this is a little bit deceptive because of the lines. It looks like there are some data points here, and then up here, it doesn't look like there's anything actually here. We can confirm that by using points instead of points. Point type 7, point size 0.5. Yeah, see. So no actual data between here and here. Just, but yeah, it's kind of interesting that it changed so dramatically. Why would it do that? Don't know. Is that like a little dust devil moving through? I mean, what would cause that to change that dramatically? I don't know. It's all a mystery. But all this is available now for scientists to grab and think about this and dive into it even more, right? I mean, we're just looking at the data. There's so much more that can be done with this. But pretty amazing. Pretty amazing. Let's see. I just glanced at the time. It looks like it's 3:04 UTC and 3:05. Just changed to 3:05. So why don't we call it again? We well, we didn't really get much more into the data release. We just looked at one more thing. We've still got, I think I want to spend maybe one more and look at some of the seismic data. So let's plan on that tomorrow, to look at some of the seismic data that they've been collecting. And yes, that's Mars quakes. They're actually looking for some kind of activity in terms of quakes. I think they're expecting to be able to detect like the impacts of meteors. Maybe they'll hear footsteps, right? Who knows, right? Maybe they'll hear some kind of a periodic thing that might be, some kind of power generator or something. Who knows, right? I doubt it. But I think I'd sort of like to look at that seismometer data. So let's do that tomorrow, and then we'll be done with InSight, at least for the moment. New data is coming out all the time on that, and we should look at it again for sure. I'm kind of interested in seeing if I can play with any of that data to make some artwork. It's kind of interesting to me. So all right. Well, I'm going to
making an ink blot thing, like the psychiatrist used to do. What do these ink blots mean?
Exactly. That's just like pure art.
Then everyone comes up with their own idea.
Yeah. Looks like the path of a weather balloon. Yeah. yeah. That's a good one. All right, everybody. I think I'm going to get out of here for now. So have a great day, a great evening. Happy aphelion. As I said,
4th.
Yes, absolutely.
And
I think we're somewhere around, in terms of miles, I think we're around like 94, 95 million miles away or so. And I think we get as close as about 90 or 91 million miles away. So yeah, we're as far out as we're going to get. So enjoy it while it lasts, because it won't. I think that is occurring at 22 hours UTC.
Get your jacket out.
Yeah, so if that's a time at your location when the sun is up, I suggest that you go outside, give the sun a little wave, and say, hey, way over there. How's it look? Way over there. So I think 22 hours UTC for me is 22 minus 7, so that's 15 hours local time. So that's 3 p.m. in the afternoon. The sun will definitely be up. So I will definitely catch a glance of the sun and give it a wave.
I will do that too. Then that'll be tomorrow about 1 o'clock my time, I think, right?
No. I think.
Or the other way.
I think you're 5 or 6 hours behind, right? So.
So 2200 is 21, 20, 19, 18, 17. About 3 o'clock.
17 is 5 o'clock. 5 p.m.
Oh.
Yeah,
5 o'clock. Okay,
right.
yeah.
It's probably daylight, so.
Yeah. So I think for us here in North America, at least, the sun
You're right.
Still be up. So it's not a requirement, but it's kind of a cool thing, to be like, okay, sun, you're as far away as you're going to be. Hello. All right, everybody. I'm going to get out of here for now. So thanks for coming in. Have a great evening, great day.
All right, thank you.
Subscribe, tell a friend.
Yep.
Thumbs up.
Tell a friend.
You tell a friend, you right there.
Yeah.
Thumbs up if you so desire. All right. I will be back here again tomorrow, 2 hours UTC, to do more astronomy. And I think we're going to do InSight one more day. Look at the seismometer data. I can get completely carried away with all this data. I could spend days and days and days looking at it, and I do. so, all right, everybody. Peace, cheers, and all that. Live long and prosper.
Yeah.
Cheers.
And trolls could just eat it.
Yes.
Mhm.
See you later. Bye, everybody.
Bye.